So any particular questions on forage testing so far?
I've got one, not so much on that, but you said about zinc is in there to prevent rust on the roofs. So what about in the fall when we get rust on forages? Is this an indication
of low zinc?
Zinc?
Zinc's involved a little bit, but the big nutrient in rust on your plant rust is a fungus. It's not an oxidation process like it is on a roof.
Yeah.
But the number one nutrient associated with rust, plant rust, is copper. If you can get more copper in your plants, the lower your rust chance, the lower the chance of rust will be. As also a lot of small grains around the country are being produced with less than optimal levels of copper. If you get more copper in, it would raise the test weight and add to the yields as well as more disease prevention. So we're used to thinking of copper as being a fungicide, an organic fungicide. However, there's a certain amount of, I think it's a research project somebody needs to do. We have the tools to do it now, and I don't know that anybody has yet. But there is a debate on how much of the copper being applied is affecting the fungus negatively, knocking back the disease, versus working from inside the plant as a systemic nutrient. I do know that the higher the copper levels inside the plant, the lower the possibility of disease attacking that plant becomes, just from field observations. It's not quantified in an actual research setting. But as Dr. Michael McNeil a couple weeks ago was speaking to a group, I was part of a conference call, webinar, and he mentioned that he's been pushing higher and higher levels of copper in his small grains in the Midwest with pretty much linear results in terms of higher copper, higher test weights, lower rust pressure. Now again, that copper, you have to have a chelated form of copper foliarly applied to get these benefits. Copper sulfate applied in the soil. Copper sulfate in the copper sulfate form is a reduced material, but as soon as that is exposed to air, it will tend to oxidize and very little of it will be available from an application. There's one more test here I wanted to show you. This is a little more of a detailed test. It's the plant Sap Test. A little more expensive. It's definitely worth doing on larger scale produce crops. Probably worth checking some cornfields with, even on a dairy farm, because it gives us the most information in terms of what's actually out there. This is the test where I determined that what I thought was nitrogen deficiency in corn was not nitrogen deficiency. There was plenty of nitrogen, but it turned out to be oxygen. This is a test. I'll just show you here how it's laid off. It tests for your potassium, calcium, magnesium, sodium, and it breaks out the nitrogen different ways. It's got ammonia, nitrate, and then total nitrogen, which includes protein. It measures chlorine, sulfur, phosphorus, silica, iron, manganese, zinc, boron, copper, molybdenum, and aluminum. And this is all taken out of the plant sap. So it's real-time data, what's in that plant to grow over the next 3 to 4 weeks, depending on the growing season. What's really interesting about this is the bar graphs, the light color and the dark color. It's older leaves and younger leaves off the same plants taken at the same time point. What that gives us is the mobile nutrients, which are your NPK and magnesium, are highly mobile nutrients. They stay mobile in the plant sap. If the older leaves are running out, the levels are dropping, it's an indication that that nutrient is likely to become limiting, because the plant's pulling out the older leaves to funnel into the new growth and feel fruit. in this case, this was a field of organic corn. You know, everybody thinks that nitrogen tends to be a limiting factor in organic corn. It is sometimes, but it's a lot less than what people anticipate. On this case, this crop did not run short in nitrogen. It had plenty of nitrogen. The levels in the new and the old were excessive. What it was running out of, it was going to be short in phosphorus, and it was going to be short in potassium. The levels of potassium are high there, but the older leaves are significantly less than the young leaves. By the time that's filling grain, that's going to be limiting the grain fill. So this is a useful test in terms of if you want to find out what the real limiting factors are in a crop. This is probably the most informative one.
And what labs will do that for you?
We send these tests to a gathering point in Ohio. The actual testing is done with a lab in the Netherlands. So they're twice a week throughout the summer, I think once a week all year round. They're overnighting from Ohio, from the collection point, they're overnighting samples to the Netherlands. They do the testing and email the results back. This is like a $5 million laboratory. For some years we were looking to try to get funding to get one over here in this country, but it appears, you know, I mentioned the testing devices that may be consumer level in the near future. A higher level of those are being worked on for agricultural use. So this $5 million lab, hopefully in the next 3 or 4 years, is going to be a $10,000 or less in-field instrument to do the same thing. The technology already exists, it's just a matter of getting it together and getting it in the field. But the system works pretty well. I mean, sending plant samples to the Netherlands sounds crazy, but in terms, you only have to get them to the collection point in Ohio. They're sending such a large volume over, the cost per sample is really not that, the shipping part's really not that great. Here's a list of plant nutrients, and the way this graph is put together, it shows the different, actually the top of it here is chopped off. But the first column of blue blocks is a photosynthesis, the nutrients that are required for photosynthesis and sugar production and transport. You know, those are the first ones you would really want to look at in a crop to make sure you had sufficient levels. And I've already mentioned those, but it's magnesium, nitrogen, phosphorus, manganese, and iron. You know, when we look at a crop, that's the first ones we want to make sure are in plentiful supply for forages and really any other crop. The second line of blue represents the protein synthesis, and those include sulfur, boron, and molybdenum. I mentioned sulfur in the equation of converting nitrogen to protein. If you have more nitrogen showing up on this forage test than you have sulfur to balance, you're automatically guaranteed to have a high free nitrogen in that forage. It's not going to do your cows any good. Also needed in that is zinc and molybdenum. Wait a minute. Boron and molybdenum are also involved in that process, kind of as cofactors. And in this setting, the protein synthesis, when you have sufficient of these nutrients, that's where you get a lot of insect resistance, and particularly your simple insects such as your corn borers and alfalfa weevils and that type of thing. These will produce proteins in the plant. If a plant's healthy enough, it's got proteins that are just as deadly to these insects as BT. BT was a shortcut, but it's not necessary. You can do the same thing with healthy plants. And we have abundant proof of that from field experience. And then the final column of blue here, we got potassium, calcium, zinc, and copper. Those are primarily, all of these are used in other functions, but these are the primary ones that impact fruit quality and fruit yield, test weight, and that type of thing. So if you're looking at a grain crop or a fruiting crop, then you need to start paying attention to these. And often, you know, we're concerned about the macronutrients. We're concerned about potassium and phosphorus. But it's just as easy to get short-circuited with things like your zinc, copper, and manganese. If they're lacking, they shut off the process just as surely as the macronutrients do. So that's basically what I've got to share with you on testing. And I just think from a whole farm perspective, if you want to be a farmer, you want your children to be farmers 40, 50 years down the road, we have to pay attention to the whole thing. And the shortcut system that agriculture has been using for the past several decades, if your volumes are big enough, if you're a big enough operator, you might be able to still continue that for a while. But for most farmers, being smaller operators, we've got to be able to tweak the system. We've got to be able to build more health into the system if we're going to stay financially solvent and viable. So any other questions?
So soil doesn't necessarily favor monoculture.
No, soil does not favor monoculture. Biology is what suffers under monoculture. Now, a little of it is okay. I'm not suggesting you need a lot of weeds in the cornfield, because corn produces so much sugar, you can really drive the biologic flywheel forward. If you're doing a monoculture of corn, you're going to narrow the range a bit, but the diversity will narrow, but the species that thrive under that will flourish, and that moves you forward. But over time, you really need a wider range of species to build resiliency into the system.
So smaller farms, more diversified, have a fighting chance against the big boys.
You have a fighting chance against the big boys, but here's where your real fighting chance comes from. It's not competing with the big boys on commodity crops. It's being ready, is looking for where the consumers want you to be and meeting them there as quickly as possible. And be aware that the testing there's no turning back. The testing that I mentioned, best case scenario, it'd be available next year, maybe worst case scenario for some farms, but it will be coming.
Can we learn anything from testing the sugar levels in our forages?
Brix meter, refractometer? Okay.
And if so, what level should we be looking for? And
Okay, here's how to use a refractometer.
Okay.
Good question. Overall sugar levels is just an interesting thing to look at. Where a refractometer is really useful is testing foliar inputs. If you go out with a foliar feed of whatever you think you need on that crop, leave a check area, go back the next day, measure the check with the treatment. If you didn't gain sugar in that treatment, you missed the boat. If any foliar you put out there should raise the sugar, or you probably didn't do what you wanted to do. So that's the most useful use for a refractometer.
what level of sugar should we be seeing healthy soil?
The rule of thumb for any crop is, it does range from crop to crop, but kind of rule of thumb is above 12 is getting good. Most of your grasses, on might say mediocre soils, will be 4, 5 maybe. Here's how we often see foliar feeds work on forage crops. You go out with a well-designed foliar feed, the nutrients that you're short in. You put it on, come back in 24 hours, 48 hours, and you'll see a sugar bump of anywhere from 2 to 6 points, depending a little on the weather and other factors. And you'll hold that for a week, maybe 2 weeks, and it'll fall off. But during that time, you're producing a significant enough greater amount of sugar that you're changing the soil biology on the treated section. So you come back and do it again in a few months or a few weeks, depending on how intensive you're managing, you'll get the same bump and it'll fall off. But if you keep doing that, and meanwhile you're getting a crop response, so it should be paying for itself, should be getting the yield and quality response. But if you keep doing that and keep changing the sugars produced, after a while your bumps will last longer and longer. And instead of falling, say if you start with a 4 and you jump to a 7 or 8, after a while, instead of falling back to a 4 a month later, it'll just be down to a 6 a month later. And then you can progress on that.
Are we starting to talk about extending the grazing season here by pumping that sugar down into the soil?
Well, we're definitely producing more forage. So if you're either extending the season or adding animals.
Yeah. I'd like to give grass to my cows for a Christmas present. That's my call.
It should be doable if you have the right species of grass.
Foliar feeds,
Such as, well, there's a lot of options out there.
okay, commercial,
You can be organic, non-organic. It's most of the ones I'm familiar with or use are organic. If you're not organic, there's some other alternatives that are a little less costly that can get the job done as well in some respects.
okay, but our foliar, do you pick your foliar feed based on?
Forage test, Sap Test, plant tests.
Okay, so you
Yeah.
see the shortages or the strengths and
You want to address
got this and
you want to address the shortages.
okay,
Now sometimes you want to address shortages as a broadcast material in the soil as well, but foliar feeding is kind of your quick response way, and it's the most economical way to address micronutrient deficiencies, because most micronutrients are only a great product to buy if they're chelated, and the dry broadcasts are not chelated.
This milk works well, huh?
Milk gives you a response at about 2 to 3 gallons per acre, and that's it. More is not better. What happens with milk, and this has been researched fairly well, what happens with milk is you spray on milk, say at 3 gallons per acre, you get a biological response, but it's a really narrow range of biology. It's not a broad spectrum range. So you get a one-time bump out of it. Doing more is not going to give you any more. It's not a calcium product. You know, I have farmers think they can spray on milk and get a calcium response. No, it's a biological product only. The actual, you know, sure, milk's great calcium as a dietary thing, but it's not the levels of calcium are not high enough to make a fertilizer grade material.
I think everybody needs to get up fresh, maybe. Maybe. Good information.